Alright, in this video, I'm going to provide the explanations for the homework questions from assignment 1.2. Alright, let's look at these questions. Alright, what you're asked to find is for what values or range of values of k such that you're given a graph, a quadratic curve, which is y equals to negative 3x squared minus 2x plus k, such that this quadratic curve have no x-intercept. What kind of values of k do you think you can substitute into the quadratic curve such that it has no x-intercept for part 1? Part 2, 1 x-intercept. Part 3, 2 x-intercepts. So what is the concept involved here? Right, first of all, recognize that the coefficients of x squared is negative 3, which is a less than 0. Hence, it is an n-shaped curve. And if you have no x-intercept, the curve will look like what you have shown on the screen. Okay, it does not touch the x-axis. It's entirely below the x-axis. So in this case here, it has no real roots. So you can relate it. How are you going to relate it to the values of b squared minus 4ac? Yes, the value of b squared minus 4ac will be less than 0. So that's precisely what we're going to do. Right, you're going to compare your quadratic curve with the quadratic expression ax squared plus bx plus c equals to 0. Write down the values for a, b, c. Substitute into your b squared minus 4ac less than 0. Okay, the important things to take note here is the values for b is a negative value, hence it's important to bracket it. The bracket must be there. Alright, so we simplify it and then you would get k less than negative 1/3 for the first part. So how about for the second part? For 1 x-intercept, so how would the positions of the curve looks like? Yes, if it's 1 x-intercept means the curve will touch the x-axis at one point. So it will have two real and equal roots. Therefore, the values of b squared minus 4ac will be equal to 0. Right, so likewise, write down the values for a, b, and c, substitute into your b squared minus 4ac, equate it to 0, and you will get k equals to negative 1/3. So now let's go on to the part 3, where it has two x-intercepts. And in this case here, the curve will cut the x-axis at 2 points, right? So in this case here, the quadratic curve has two real and distinct roots, and therefore the values of b squared minus 4ac will be more than 0, right? And you end up getting k more than negative 4/12, which is k more than negative 1/3. Right, so in this question here, basically you're just dealing with how the values of b squared minus 4ac determines what types of roots a equation have. Or you can look at it this way, the type of roots a equation have will actually determine what kind of values your b squared minus 4ac have. Right, let's look at another question. So you're given y equals to ax squared plus bx plus c, and this quadratic curve has two x-intercepts. Alright, and you're asked to show that AC is less than b squared over 4. So if the quadratic curve has two x-intercepts, it depends on the value of a, right? Your a can be positive or a can be negative, right? But in both situations, whether a positive or a negative, if the curve has two x-intercept means the curve has two real and distinct roots. And if that is the case, then the value of b squared minus 4ac has to be more than 0. Right, so we substitute b. So the values, the b is the coefficients of x. So in this case here, it's just b. So we just substitute b as b. Alright, and the coefficients, a is the coefficients of x squared, which happens to be a here also. So a remain as a. likewise for C as remain at C. So you end up getting b squared minus 4ac b squared minus 4ac more than 0. You add 4ac to both sides, you get b squared more than 4ac. Right, so we're going to shift the position. Now, you will see that this big mouth is facing b squared. That means your b squared is more than 4ac. So when you shift the position, when you make 4ac on the left hand side, make sure the 4ac is less than b squared. Okay, make sure that the big mouth faces your b squared. So 4ac less than b squared, the next step is that we're going to divide by 4 on both sides. And we have ac less than b squared over 4, which is exactly what you're asked to show. So therefore, we just put a bracket shown. And that's how you solve question 5. Alright, so this question has two parts here. The first part is to find the intercepts. So the intercepts refer to the x-intercepts, also the y-intercepts, and the coordinates of the turning point on the graph. You're given a quadratic graph. Right. The second part, you're supposed to explain why the negative 2x squared plus 4x equals negative 3, a quadratic equation, has two distinct real roots. So first of all, let's zero into this word, two words, turning point. What does turning point means to you? Right, when do you actually encounter turning point? Yeah, we encounter turning point in chapter 1, where we need to express the quadratic functions in the completed square format. Right, if you were to recall, y equals to a bracket x minus h close bracket square plus k, the turning point will be h comma k. So your turning point here, if you recall, it can be maximum, minimum, depending on the values of your a. If your a is more than 0, then it is a U-shaped curve that gives you a minimum point. Right, U-shaped curve, where the values of a is more than 0, that gives you a minimum point. If it's an N-shaped curve, where the values of a is less than 0, that will give you a maximum point. So minimum point, maximum are classified as turning point. Right. So how do you go about finding this turning point? Yes, you would have to apply completing the square method, the skill, completing the square skill, to convert this quadratic curve into the completed square form. So we need to factorize, we need to make the coefficient of x squared to be 1. Right, so we have to factorize negative 2 out from your first two terms, the x squared and your x term, leaving your positive 3 alone. Okay. Then the next thing is that, yeah, we apply the method. Okay, so we need to add 0 into the coefficients of x, which is negative 2, divide by 2, square it. You need to add that, then take it away. Right. And not to forget also, we still have a plus 3 there. Then the next step is, right, the next step is, okay, the first three terms in the bracket here, right, will collapse into your square form. And then if you use a calculator to work out this term here, it gives you negative 1. Right. The next step is you have to multiply the negative 2 into your square bracket. And take note, very important, take note that here your negative multiplied with this negative here will give you the positive 2. And again, not to forget your plus 3. You still have a plus 3 here, not to forget it. Okay, and you simplified it to be negative 2 bracket x minus 1 close bracket square plus 5. So that will be a completed square format for your quadratic curve. Alright, so what would the turning point be? Okay, so there are three things we need to find: the intercepts and also the coordinates of the turning point. Right, so the turning point would just be 1, 5. Why just 1, 5? Because the minimum value, the maximum value for this curve will be 5. Maximum value of this curve will be 5, right? And to get maximum value to be 5, x minus 1 is equals to 0. So x is equals to 1. That's how we get our turning point 1, 5. So the next thing we need to do is to find your intercepts value. So to find the x-intercept value, basically you just let y equals to 0, because the x-intercept are found on the x-axis. So that's when y equals to 0. Right, so you let y equals to 0 and you solve it, and you would have 2x-intercept, which is 2.58 or negative 0.581. Alright, and we still have to find the y-intercept value. So how do you find the y-intercept value? That is when you let x equals to 0, right? And the easier way to do it is just to substitute x equals to 0 into this raw form of the quadratic curve that you're given in the question. And you have your y-intercepts equals to 3. Alright, so this is the solution for part 1. Let's go on to part 2. Right, so for part 2, we need to explain why is it the quadratic equation given there has two distinct real roots. So from part 1, okay, first of all, we need to understand that the real roots of the equations negative 2x squared plus 4x plus 3 equals to 0 are actually the two x-intercept, which we found earlier on in part 1, which is 2.58 and negative 0.581. So therefore, and this 2.58 and negative 0.581 are two real and distinct roots. They are not the same. They are unequal roots, unequal values. So therefore, we conclude that negative 2x squared plus 4x plus 3 equals to 0 has two distinct real roots. That's how you answer part 2. That's all. Okay, let's look at question 10. So far, let's summarize what we have just applied. Basically, we just examine your quadratic curve, examine the values of a, which is the coefficients of x squared. If it's positive, it's U-shaped, negative, it's N-shaped. Alright, examine what kind of roots are given, and from what kind of roots are given, right, we determine the values of b squared minus 4ac. Okay, so basically this is what we have been just keep doing it. Okay, so if you look at 10a, right, this is what I've just explained. Okay, the coefficients of x squared is 2, more than 0, it's a U-shaped curve. And because the questions require your curve to be always positive, means the curve is entirely above the x-axis. So therefore, it does not have any x-intercept. So therefore, there is no real root, and therefore, the values of b squared minus 4 is less than 0. So this is the concepts that you must have, okay, before we can go solving it right. So once you have this concept, it's very easy. We know that you just have to use b squared minus 4ac less than 0. Substitute into the values of b, which is 2, values of a, which is 2 also, values of c, which is k. Right, solve it, you get a quadratic inequality. You get a inequality, not quadratic inequality, just inequality, right? And then you will have k more than half. Right, so if you look at part B, right, we use the same reasoning as what we have done earlier on for part A. Okay, observe that the coefficients of x squared is negative 3. It's a negative value, means the curve has to be N-shaped curve, and if it's always negative, means it must be entirely below the x-axis. So such a situation means there's no real roots. It means that the value of b squared minus 4ac is less than 0. So therefore, similarly, we apply b squared minus 4ac less than 0, sub in the values for b, a, and c. You end up getting an inequality. Alright, you solve it, and you will get k less than 2. K less than negative 2, sorry. The only thing that I want you to take note is, alright, because there are 3 terms here, so you should always try to just simplify the first 2 terms to get 12. Okay, then multiply with the k minus 1. Simplify the first 2 terms first, and then multiply it with your third term. And also here, okay, oh, that's fine. This one is quite alright. I think this is the one that I want to talk about. Okay, if you add 8k to both sides, you end up getting 4 less than 8k. So when you shift 8k to the left hand side, make sure the big mouth faces 8k. 8k is more than 4. So when you shift 8k to the left hand side, make sure you also change the inequality sign. Okay, the big mouth must face 8k. Right, let's look at part C. Alright, so if you understand how to do part A and B, so part C, it's not difficult. Right, so you're told that the graph lies entirely above the x-axis. So that's very easy. You are already told how the positions of the curve will look like. Right. And therefore, if the curve is entirely above the x-axis, it does not touch the x-axis, means there's no x-intercept. If there's no x-intercept, means there's no real roots, and hence the value of b squared minus 4ac is less than 0. So we just applied b squared minus 4ac less than 0. Substitute in the values of b, which is 1. Substitute the values of a, which is 2. Values of c is negative 2k. Right, you will get an inequality. Right, like what I've mentioned earlier on. Take 4 times 2 first to get 8 here. And then negative 8 times negative 2k to get 16k. And therefore, you will get k less than negative 1 over 16. Okay, let's look at question 12. Question 12 is relatively easy. Yeah, because you just need to explain why the graph of y equals to 2x squared plus 4x minus k plus 1 has no x-intercept when k equals to negative 5. So you just need to ask yourself, what do you do with k equals to negative 5? K can take any value, right? But in these questions here, they require you to take k equals to negative 5. So what do? Yes, you just substitute k equals to negative 5 into your quadratic curve. Right, so the explanation is there. So again, we start off by observing that the coefficients of x squared, it's 2, which is positive. So the curve is a U-shaped curve. So if the curve has no x-intercept, means the curve has no real roots, and the curve must be entirely above the x-axis. So therefore, the values of b squared minus 4ac is less than 0. But here, you must be very careful. Why careful? Because you can't use b squared minus 4ac less than 0 straight away. You need to, you see, the question asks you to explain. So explain something is the same as to show evidence. You need to show evidence, that when k is negative 5, your quadratic curve has no x-intercept. Therefore, you can't just use b squared minus 4ac less than 0. You can't do that. Okay? What we need to do is we need to substitute k equals to negative 5 into quadratic curve. Find the value of b squared minus 4ac. Find this value. And show that this value is less than 0. So how do we do it? Right, so the first step is substitute k equals to negative 5 into a quadratic curve. Simplify it, you get y equals to 2x squared plus 4x plus 6. Next step is compare it with your general form, which is ax squared plus bx plus c, write down the value of a, b, and c, substitute into b squared minus 4ac. Can you see here in this case, I do not write, okay, I do not write b squared minus 4ac less than 0. I do not write this. I wrote here b squared minus 4ac only, okay, only. And then I sub in my values of b, a, and c, and I end up getting a negative 32. And negative 32 is less than 0. And then I do some explanation. What's the explanation that I do? I explain that since the value of b squared minus 4ac is less than 0, therefore the graph has no x-intercept when k equals to negative 5. Okay, so this kind of questions, let me repeat. You cannot start off by saying b squared minus 4ac less than 0. You cannot start off by writing this. Okay, no, you cannot. Right, you have to go find the values of b squared minus 4ac like what I've done here. Find that it's negative 32. Then conclude that since negative 32 is less than 0, the graph has no x-intercept where k is negative 5. Okay, let's look at the next question. Part I. Prove that 2x squared plus 2x is greater than negative 4 for all real values of x. So here again, if you're asked to prove or explain or show, right, you can't write things like b squared minus 4ac is more than 0, b squared minus 4ac equals to 0, b squared minus 4ac is less than 0, so on and so forth. You can't do that. Okay? And if you look at 13 part 1, I don't think we're going to use discriminant. Okay? Because discriminant basically it's used when the quadratic curve given or quadratic inequality given has an unknown. If what you're given has no unknown, then we should apply the completing the square method. So if you look at 13 part 1, there is no unknown there. It's just 2x squared plus 2x, and you need to prove that for all real values of x, 2x squared plus 2x will always be more than negative 4. So here then we will have to apply completing the square method to, okay, so let's look at how we do it. Factorize 2 out, because to apply completing the square method, we have the big coefficients of x to be 1, right? Okay, so from there we need to do some explanation. So what's explanation? How do we go about explaining it? Yes, x plus half to the power of 2 will always be positive, more than or equal than 0. If you multiply by 2, you still get right hand side 0. And the next thing I'm going to do is to add negative. Oh, sorry, what do? I have to add negative half to both sides. Yeah, why negative half? Because look here, this is the completed square form, right? Yeah, so when I add negative half to both sides, what you're getting is the maximum value is negative half. And if you look at the number line, negative half, definitely it's more than negative 4. So hence we have proved that 2x squared plus 2x will be more than negative 4 for all real values of x. Okay, so this is how you do proving questions. Let's look at part 2. So part 2, you ask to explain then why the graph has no x-intercept. Yes, your 2x squared plus 2x more than negative 4 can be simplified into 2x squared plus 2x plus 4 more than 0. So what we are saying is your curve is entirely above the x-axis. If you're going to replace this guy with y, as what you're given here, then your y is more than 0. That means there's no negative values for y. Hence your curve will be entirely above the x-axis. So if a curve is entirely above the axis, there's no x-intercept at all, right? And that explained, and that conclude the solutions for part 2. Okay, let's look at question 16. All right, so we're going to do the same. What do you mean by do the same? The 4 steps or the 3 steps that we usually do. Right, look at the coefficients of x squared. Determine whether U shape, N shape. Determine whether if it's entirely above the x-axis or entirely below the x-axis. Right. And then from there, we determine what values of discriminant we should be using. Right. So if you look at the explanations that I have on the screen, the coefficients for x squared is 1 more than 0. It's a U-shaped curve. Right. And if you're asked, if you're said that the curve is more than 0 means your y values are all positive, means the curve is entirely above the x-axis, means no real roots, means the value of b squared minus 4ac is less than 0. So this is exactly what we're going to do. Okay. Right, and you get m less than negative 21. Right, so can you see that the concepts that we're talking here are just basically 3 or 4 things. All right, identify the coefficients of x squared, identify whether U shape, N shape, identify whether if it's entirely above above the x-axis or entirely below the x-axis, or it cuts the x-axis, or it just cuts the x-axis at one point, how many x-intercept we have, and then from there conclude what kind of value of b squared for minus 4ac that the curve has. Right, let's look at part B. Okay, right, so but to do part B, right, it's a bit more challenging because part B, you have this huge guy here that you need to expand. So therefore, I actually show it here. That will be the values for C. So I show it here how you can expand it. Basically, we just expand the first 2 terms first. Just take negative 4 multiply with k minus 1 to get negative 4k plus negative 4k plus 4. Then multiply with k plus 2. Right, use the distributive law, and then you end up getting a quadratic expression. Okay, right, and we used b squared minus 4ac less than 0. Sub in the values for b, a, and c. Right, simplify it. There's a lot of algebraic manipulations there. Be very careful, and you get k more than 2. That's how you solve part B. Oh yeah, I need to provide the explanation first. So that is the explanation given there. Okay, observe that a is equal to negative 1 less than 0, hence the curve is an N-shaped curve. If the curve is less than 0, means it's entirely below the x-axis. So therefore it has no real roots, therefore b squared minus 4ac is less than 0. Okay, so I should have shown this part first, but never mind. I think we've done enough questions that now your concepts should be very, very sound. Okay, so to summarize, what are the things we need to do? Right, we need to identify whether it's U-shape, N-shape, identify whether if it's entirely above or entirely below the x-axis, above, below, or cuts the x-axis at 2 points or intercept the x-axis at 1 point. Then from there, we can determine whether it has 0, 1, or 2 x-intercept. 0 x-intercept means no real roots. 1 intercept means 2 real and equal roots. 2 x-intercept means 2 real and distinct roots, and from there we determine the values of b squared minus 4ac. Okay, that's all.